Tony Eller from RealClimateScience.com, the climate guy setting the record straight about climate. This video is titled, NASA Debunks Global Warming Theory. In this article on the NASA Climate Kids website, they explain how Earth is like a greenhouse, and they say, during the day the sun shines through the atmosphere. Earth's surface warms up in the sunlight. At night, Earth's surface cools, releasing the heat back into the air. But some of the heat is trapped by the greenhouse gases in the atmosphere. That's what keeps our Earth a warm and cozy 59 degrees Fahrenheit on average. People in Siberia might disagree with NASA's assessment that Earth is being kept a nice, cozy 59 degrees by global warming. This year, Siberia has been reporting the coldest weather ever recorded outside of Antarctica. This year has also brought record cold to the eastern U.S., record cold to Bangladesh, snow in the Sahara for the second year in a row, snow in Saudi Arabia, and it looks like this may be the coldest Olympics on record coming up in South Korea. But let's get back to the greenhouse effect. NASA claims that Venus is extremely hot due to a runaway greenhouse effect. Let's look and see if that claim makes any sense. Venus is extremely hot. Temperatures there average almost 900 degrees Fahrenheit. They're hot enough to melt lead. And the temperatures there don't vary from day to night. This is what Space.com says about Venus. The distance to Venus from the sun plays only a small role in the cause of its elevated heat wave. Temperatures on Venus remain consistent over time. For one thing, the planet takes 243 Earth days to spin once on its axis, and it spins backwards at that. On Venus, the sun rises in the west and sets in the east. The nights on Venus are as warm as the days. Let's think about the implications of that last paragraph. Nights on Venus are extremely long. They last for more than 6 Earth months, yet the temperature doesn't cool down at night on Venus. Does that match NASA's description of a greenhouse? Remember, NASA says that the greenhouse effect is heated by the sun and that it cools down at night, yet Venus doesn't cool down at night. Additionally, Venus' surface receives very little sunlight during the day because it has a very thick cloud cover. So there's little sunshine during the day, and they have a very long night, yet the temperature never changes on Venus. That obviously can't be the greenhouse effect that's causing the heat on Venus. I've been pointing out for nearly a decade that the very high temperatures on Venus are not due to a greenhouse effect. They're due to its very high atmospheric pressure. The atmospheric pressure on Venus is about 90 times higher than it is on Earth. It's the same reason why the top of the Grand Canyon is cold and the bottom of the Grand Canyon is hot. The only difference between the top and the bottom of the Grand Canyon is the atmospheric pressure, which is much higher at the bottom. Chemists have known this for centuries, that if you increase the pressure on a gas, the temperature increases too. If you pump up your bicycle tire, the pump gets hot for the same reason. You're doing work to the gas by increasing the pressure, and that increases the temperature. The sun is constantly doing work to planetary atmospheres. That's what keeps the pressure and thus the temperature up. If the sun went away, the atmospheres would collapse, there would be no atmospheric pressure, and the temperature on the surface would approach absolute zero. But the fact that we have a sun which is constantly doing work to the atmosphere, that's what allows the pressure gradient to remain, and that's why the temperatures in the lower atmosphere are hot and the temperatures in the upper atmosphere are cold. As I said, I've been pointing this out for a decade and been getting criticism from ridiculous websites like Skeptical Science. Let's look at temperatures and pressures on the different planets. Venus has a 95% CO2 atmosphere and has a very high atmospheric pressure. It's extremely hot there with temperatures hot enough to melt lead. Mars also has a 95% CO2 atmosphere, but the pressure is very low and it's extremely cold there. Jupiter is much further from the sun than Mars and has a very high atmospheric pressure, and temperatures there are incredibly hot in the lower atmosphere. They're actually hotter than the surface of the sun. So distance from the sun can't explain the hot temperatures on Venus because Jupiter is even hotter and it's much further from the sun. Atmospheric composition can't explain it because Mars and Venus have the same atmospheric composition, yet Venus is very hot and Mars is very cold. And the last thing to consider is the lapse rate. The lapse rate on Venus, which is the rate which the temperature increases as you go down in the atmosphere, is very similar to Earth, even though Venus has a very high CO2 atmospheric composition and Earth has a very low CO2 atmospheric composition. So we can't explain planetary temperatures based on distance from the Sun because Jupiter is 500 million miles from the Sun and its lower atmosphere is extremely hot. We also can't explain planetary temperatures based on atmospheric composition because both Venus and Mars have about 95% CO2 in their atmospheres, yet Venus is extremely hot and Mars is extremely cold. The only property of an atmosphere which is useful for predicting planetary temperature is the atmospheric pressure. Jupiter has extremely high atmospheric pressure in its lower atmosphere and it's extremely hot. Venus also has very high atmospheric pressure and its temperatures are very hot. Earth has moderate atmospheric pressure and we're warm. Mars has very low atmospheric pressure and they're very cold. So it's very trivial to explain that planetary temperatures are controlled by atmospheric pressure, not composition, not distance from the Sun. The Sun is the energy source which provides the heat, but the temperature profile is controlled by the atmospheric pressure. It's very basic science. Now let's get back to NASA. In 1971, NASA's two top climatologists told us that a runaway greenhouse effect is impossible. This was Rasool and Schneider. The main conclusion of this part of the study is that even an order of magnitude increase of CO2 in the atmosphere by human activities, which at the present rate of input is not expected within the next several thousand years, may not be sufficient to produce a runaway greenhouse effect on Earth. In 1941, the year Bernie Sanders was born, the Department of Agriculture published a study saying basically the same thing. No probable increase in atmospheric carbon dioxide can materially affect either the amount of insulation reaching the surface or the amount of terrestrial radiation lost to space. They're saying that a runaway greenhouse effect, or even an enhanced greenhouse effect, is impossible. In 1901, Knut Engström did a very important experiment which showed that increasing the amount of carbon dioxide in the atmosphere would have very little impact on temperature or the radiative balance of the atmosphere. This was because almost all of the long-wave radiation in the CO2 spectra was already being absorbed. And therein lies the fundamental problem with global warming theory. Increasing the amount of CO2 has very little impact on the radiative balance of the atmosphere because almost all of the long-wave radiation which can be absorbed by CO2 is already being absorbed. Let's summarize this now. Venus behaves nothing like a greenhouse because they receive very little sunlight during the day and they don't cool at night. The temperature gradient through Venus' atmosphere is very similar to Earth, even though the atmospheric composition of Venus' atmosphere and Earth's atmosphere are very similar. If Earth had similar atmospheric pressures as Venus, we would have similar atmospheric temperature, even though Venus has a huge amount of CO2 and Earth has a very small amount of CO2. Both Venus and Mars have 95% carbon dioxide in their atmospheres, yet Venus is very hot and Mars is very cold. It obviously is not the chemical composition controlling the temperature. Distance from the Sun also can't be controlling the temperature because Jupiter is very far from the Sun and its lower atmosphere is extremely hot. Mars is much closer to the Sun and it's extremely cold. And scientists have known for over a century that almost all of the long-wave radiation in the CO2 spectra is already being absorbed, and thus adding more carbon dioxide to the atmosphere has very little impact on the radiative balance of the atmosphere. The only reliable predictor of atmospheric temperature on the different planets is the atmospheric pressure, and that works flawlessly. One of the first people pushing the runaway greenhouse effect theory was Carl Sagan, who also brags about being stoned all the time. Visit Toto on the web at realclimatescience.com. He's been pulling back the curtain on junk science for a long time.